This is our project, and it is known as notebook. And in this notebook, you can create various data structure visualization algorithms. And for now, we have just made graphs. So you can just implement greedy algorithms on the graphs, the two famous greedy algorithms, which is Kruskal and Prim's algorithm. So you can see over here, we have a create button over here. So if you click over here, you can select the type of graph and the algorithm. So currently, as we are using the greedy algorithms, we only have two of them, Prims and Kruskal, and the greedy algorithm didn't apply on the directed graph. So this feature is not available yet. So you can go for the direct undirected graph for now. So just select the graph over here, and the simulation will be created according to your selection over here. So if I just go down, and over here you can see the developers introduction, the social media handles, and over here I have also provided these 3D simulations. So make the page more interactive to the user, like that. And these are the introduction. Now let's move on to our graph over here, and let's start a simulation. So over here, this is a simulation page for the Prim's algorithm. So in this page, you can see there is a whiteboard on which we are going to draw our graph. And on the left hand side, you can see a panel. In this panel, we have provided various features like to get the current algorithm. So currently we are using the Prim's algorithm. So if I select this, you will see the Prim's algorithm step by step. So if someone want to understand the algorithm before going on to the graph, they can click over here. Now, this is a code section. So over here, I have provided the code which is running behind the scenes for the Prim's algorithm. And if someone want to see this, they can come over here. Now, this is a button which is used for creating the minimum spanning tree, which for the graph which is created on the whiteboard. So currently, as there is no graph on the whiteboard, so if I try to click over here, it will tell me to add a node. So you cannot create a graph, and obviously also add an edge. Now I will create on this add a node button to create a graph. So let me write a node name. Let's say it is A. So as you can see, this is our node is created. Now let me create one more node. So this is node B. Now if I try to create the minimum spanning tree now, what it will say? It will say that the make sure the graph is closed. So this message is for whenever you create a disjoint graph. So currently you can see this is a disjoint graph, or the graph is not a cycle. All the nodes are not interconnected with each other. So this message is going to display. So let me create 4 nodes for now to create a complex graph. Let's say it is C, and let's say it is D. So these are our 4 nodes. Now let's connect them with an edge. A to B, let's say it is 10, B to C, let's say it is 50, C to D, 4, and D to A. Let's say it is 9. So currently, if I try to create the spanning tree, it will make it, because the number of nodes and the number of edges are equal. So as you can see in the spanning tree, the number of edges should be n number of nodes minus 1. So it will create the minimum spanning tree. So let me make it more complicated. Let's connect C and A. Let's make it 66. So now if I try to create the minimum spanning tree, so for now let's predict what will be the answer. As you can see over here, 66, 66, 50 should be gone from here, because these are really big edges. So if I click on minimum spanning tree, you can see this is our final graph. So as you can see, number of nodes is 4 and number of edges is 3. So behind the scenes, here the Prim's algorithm is being used, and this is your final answer, like this. Now let me take you to the Kruskal algorithm. So this is the page for Kruskal algorithm. The page is very similar, and the algorithm working is different, but the algorithm is different over here. The Kruskal